Okay, hello everyone. Good morning. This is Ed. Today we are going to. This is our the second episode of Hands-on TiDB, and today I'm going to uh, show you how to deploy and do the benchmark uh, of TiDB on AWS. And okay, previously, we in the episode one, I gave a brief introduction of TiDB, and this is the slides link and video. And after this webinar, after this episode, I will also put this the link of the slides and the video to upload to YouTube, and you can find the link on the YouTube comments. So today I'm not going to introduce a lot of details of the components of TiDB, and we are focusing on the deploy and benchmark. What's the machine type? What's the hardware requirement for deploying in production TiDB cluster? Again, a little bit introduction. My name is Ed. I'm the co-founder and the CTO of PinCap. This is my email and the Twitter handle. So if you have any following questions, just feel free to ask me. Send email to me. Okay. So where can I deploy TiDB? Basically, I think TiDB is it is an open source database. It is platform agnostic. Basically, you can deploy the TiDB on any Linux server, on any Linux box, both bare metal or on the public cloud. Both of these are okay. But for the in production usage, we have some Linux version kernel version requirement. Like for example, we only support the Red Hat Linux with 7.3 or later version, CentOS, Oracle Enterprise Linux, Ubuntu. It is 16.04 or later. Because we have some, we use some API that the Linux kernel have to support at least 3.10 the Linux kernel version. Basically in our own data center, we will test the TiDB on Ubuntu, CentOS, and the Red Hat Linux. So it is what we recommended for the user to use TiDB in production. Before the introduce of the deployment on AWS, I want to do a quick introduction of the hardware required recommendation for bare metal machine. All of these are recommended for the in production usage. For example, TiDB, if you want to deploy a TiDB server on your bare metal machine, the CPU at least 16 V-core virtual CPU, 60 threads. The memory at least 32 gigabytes because for example, if you have some complex query, it will use a lot of memory. TiDB is not required SSD because it will not persist data locally. So use any hard disk you want. So HDD is okay. And the network, at least 10 gigabytes network. The placement driver, the metadata storage system. It is we don't have special hardware requirement for PD, but at least you need at least 3 nodes for the high availability. And the TiKV node is where the data is stored. It is I/O intensive, so the most important thing for TiKV is you have to use NVMe SSD. And because the underlying storage we are using inside TiKV is RocksDB, and the RocksDB RocksDB have a lot of optimizations for the SSD. For the performance, for better performance, you have to use NVMe SSD for TiKV. And TiKV also deploy at least 3 nodes for the high availability thing. And the monitor stack like Grafana, Prometheus, the metrics, collecting. I suggest you to put another nodes for the monitor. You don't have to use some fancy hardware for the monitor. It is very easy to understand. So basically, in the world, TiDB server is a CPU intensive component. So use the high-end CPU, the more cores, the better. And the TiKV server is both CPU intensive and I/O intensive. But for TiKV server, the CPU usage will be less than TiDB server, so you don't have to use as many cores as the TiDB server has. But one of the most important things is TiKV always have to use local NVMe SSD. It is a necessary thing for the in production deployment. The PD server, no special requirement, but need multiple nodes for HL for high availability. Basically, you can use some virtual machine for PD, and some best practice is if you are deploying TiDB across different data center, you may put the PD server across different data center for the better high availability. I would, on the other hand, just like I mentioned, it is a hardware requirement for the bare metal machine. And what's the hardware recommendations for AWS, deploy TiDB on AWS? Let me get a very straightforward example. For example, you have very serious OLTP workload, and the PD and the TiDB, I suggest you to use C5 for X large. It is a 16 core vCPU and with 32 megabytes memory. And the disk is EBS, so you don't have to use the local disk because the PD and TiDB will not persist data locally. And for TiKV, I suggest to use i3 for X large, the IO optimized the IO optimized machine. It has 16 vCore, more than 100 gigabytes memory, and have two terabytes NVMe SSD. Is very powerful. It is, and notice that you can deploy 2 TiKV server instance on each i3 for X large node because it has 2 SSD disk. So it is okay to deploy multiple TiKV server on one node for the best IO usage. And this deployment, it is kind of like one of our in production users use this use this machine for their OLTP workload. And for the workload like this, 50% slash 25% update, 25% insert. Most of these SQL statement transaction are the simple query, not a very complex query. Most of the select is point, select, and update, insert happen in 1 or 2 rows. Each row is not very big. So for the workload like this, and this cluster will handle the peak TPS is about 90K transaction per second, and the hardware cost is about 150K per year, and it is the reasonable hardware cost for the serious OLTP workload on AWS. And on the other hand, for example, if you want to do some benchmark using something like Sysbench to do the benchmark, and you don't want to deploy the very high-end i3 4x large machine, you can also use C5D 4x large for the benchmark, for the Sysbench benchmark. In PinCap, we are using C5D for the in-house testing. So it is also a good recommendation for the users to deploy TiDB on AWS. And in our test, for example, in this case, we have 5 TiKV server and 2 TiDB servers, 3 PD server, and we deploy all these components across this 5 C5D 4x large machine. And notice that we have 5 Sysbench node. Each node is a T2 2x large machine, and we open 5 Sysbench process on 5 nodes and send the benchmark in parallel to this cluster, and the result is pretty good. Why we launch 5 Sysbench process is because sometimes the Sysbench process or the Sysbench node becomes the bottleneck of the system. The bottleneck is not on the TiKV node or TiDB node. It is Sysbench itself. So for this situation, we will launch multiple Sysbench to send the benchmark workload to the cluster. And the Sysbench result of this cluster is about, for example, the OLTP point select is more than 177K for the point select. And the read-only TPS and QPS is also pretty good. And this is the OLTP update 1 single row without index. This cluster 5 C5D 4x large machine have 42K TPS in this deployment. And this is also some benchmark result of something like OLTP update index and OLTP read write and insert. Yeah, the result is not bad, right? Before we start the demo, because we we are going to have a long demo today. So before the demo, I want to share some tips for running Sysbench on TiDB. And the first thing is make sure you open the prepare plan cache in the TiDB configuration. It will reduce the TiDB servers CPU cost dramatically. And another thing is that remember to use the rand type equals to uniform, the uniform rand type for the Sysbench. It will generate the uniform distribution workload for the cluster, which is very good for simulate the random workload, which is good for TiDB. And also, just like I said, you have to make sure that Sysbench node itself, it is not the bottleneck. You can check the CPU cost of Sysbench. For example, if your Sysbench node has 100% of CPU usage, that means, and the TiDB CPU and the TiKV CPU and IO, it is kind of idle, and you can, but the Sysbench node is 100% CPU, so you can, that means the Sysbench itself becomes the bottleneck. And another tip is use OLTP. We have a modified OLTP common .lua this file. We have a little patch for speeding up the data importing process to TiDB. And basically, it is in general, it is we made the data import in parallel, which is good also good for TiDB. And another important thing is that before you do the Sysbench or the performance benchmark, make sure you go through the Sysbench test result of TiDB 3.0. And this document, it is not only the benchmark result, but also some tuning configuration and some FAQ, the common issue, and make sure you don't have these following questions before you start the test. Okay. On the other hand, we have two ways to deploy TiDB on AWS. Both of these are starting with the Terraform. So we made it very easy for the we use Terraform for making it easy for the user to deploy the TiDB components on AWS, both EC2 and the EKS. Yeah, right now we have two ways. One is, for example, we use Terraform to provision the AWS EC2 machine and deploy TiDB Ansible to the EC2 machine, and using Ansible to deploy the whole TiDB components. Or we can use the EKS because TiDB is supports Kubernetes deployment. So that means we can also support the EKS, and it is the recommended way for deploying the in production TiDB cluster on AWS. We will encourage users to use Kubernetes deployment on AWS, because even though you use Ansible, that means you still have a lot of manual operations using Ansible, which is not good. So yeah, what's behind the Kubernetes deployment? It is a project we call TiDB Operator. Operator is a common methodology for deploy, maintain the large-scale distributed system on top of Kubernetes. And basically we put a lot of TiDB deployment, maintenance, the failover, the scale out, all of this operational knowledge into the TiDB operator and inject to the Kubernetes and make Kubernetes let Kubernetes can handle the operation for multiple TiDB clusters. And in the future, TiDB on Kubernetes it will be the standard way to deploy on public clouds, and we don't encourage users to deploy TiDB on public cloud manually in the future. Okay. So what does TiDB operator do? The first thing is bootstrap the whole TiDB cluster, deploying the PT, TiDB, and the TiDB servers. And also the TiDB operator will manage multiple TiDB cluster. For example, if you want to deploy multiple TiDB cluster on the Kubernetes cluster, and you want to do some resource isolation, some multi-tenant thing, TiDB operator will help you. And because of the nature of distributed system, the rolling upgrade is very hard. So we put the automatic rolling upgrade to this feature to the TiDB operator, so you don't have to worry about how to manually rolling upgrade every comments inside TiDB. So it is the building feature of TiDB operator. And of course, the scale out, failover thing. And we also maintain because in TiDB we have to use the local local disk. So the TiDB operator will also maintain the local disk resource for Kubernetes and for TiDB. Okay, just like I said, today we have a long demo. We are going to have two demos. One is using Terraform to deploy TiDB cluster on EKS, and another is using Terraform to deploy the TiDB cluster on EC2 and run some Sysbench on it. Both of these demo we both provide the Terraform script to help users to deploy this whole stuff easily. So let's go. Why not we start from the Ansible thing? So let's see. So this is the repo. You may notice that this right now it is still the personal repo, but we will merge this repo to the official TiDB Ansible repo soon. Can go to the README and see how to deploy it. It's very easy. Okay, Terraform init. Make sure you have the Terraform installed in your laptop. Okay. Terraform plan that will output the deploy plan for you, and you can also have a kind of like the dry run. Yeah, as you can see, this Terraform script will create the security group, provision the nodes, prepare the nodes, things like this, and deploy the TiDB Ansible on the EC2 instance. And Terraform apply. That will start the deployment. Okay. Well, that will take I think it will take a few minutes to launch the instance we need, and we can see the instance here. Yeah, it is start launching nodes. This is my AWS dashboard, so you can see we have 3 i3 2x large for TiKV nodes, and C4 4x large for TiDB server, and have 3 T2 micro for PD server. Most of them are in the same data center because we want to do some, Sysbench, the performance bench. So deploying one data center is reasonable. And in the meantime, I want to show you how to deploy the TiDB operator on EKS. Just deploy TiDB on Kubernetes, basically. But launching open a new EKS will cost a lot of time. So I recorded a video last night. It's also very straightforward. As you can see, this is the repo of the TiDB operator, and also Terraform init, cd to the deploy AWS this sub directory. And it will Terraform will download the plugin it needs. And as you can see, the whole progress is about 15 minutes. Most of the time is waiting the AWS to create a new EKS cluster. So I don't want to wait 15 minutes, just watch the dashboard waiting the EKS creating. So I record the video so we can jump the waiting phrase. There you can see we put some variables in the variables.tf, and you can change some variables and just Terraform apply, and the system start to deploy, start to launch the new EKS cluster for you. And it will take a long time, like 12 minutes, because it will take a long time just for the AWS to creating the new Kubernetes cluster. And okay. And after the deploy all the components, we can see apply complete, and we have a relay server IP, and it's very simple. I'm not destroyed. I haven't destroyed the cluster I built last night, so we still can use Kubernetes client to show the cluster we created last night. Here you can see we have 3 TiDB nodes, 2 TiDB nodes, and 3 PD nodes on this Kubernetes cluster. Let's see what's wrong. And on the Ansible side, we will do some, install the library we need. We will mount the disks for you, so you don't have to worry about to manually tuning the system. We'll do that for you. And the Terraform script will also download the TiDB binary. So all you have to do is only Terraform apply. And in the meantime, we can play around the Kubernetes cluster. And see, we can jump into the pod we have. For example, we can jump to get the cell of one of the PD node. And this cluster is all run on top of Kubernetes. So that means all of these are running. All of these processes are running in containers. You can see the PD is a 4 core CPU, 4 CPU for our PD node. And let's see TiDB. TiDB is 8 core CPU. And why not we run some benchmark on the Kubernetes cluster. Yeah, okay. And last night I created this see, the Ansible is still deploying.
While you're doing that, Ed, I just want to say that we're at 30 minutes. And for anyone who has any questions, feel free to type it in, and we will get to questions very soon.
Okay. Yeah, last night I created 2 YAML file for the Kubernetes. Very simple. It will launch a Sysbench pod on your local on your Kubernetes cluster. Let's slide this. Yeah, this command means we will launch a Sysbench pod on the cluster. The namespace is TiDB. So let's see. Yeah, we have a Sysbench pod running. And we can get a cell of this pod. And yes. And like I said, please read the Sysbench documentation before we start the benchmark. The first thing is to make sure the prepared client cache is true, but I'm not going to change this because I only want to do the quick benchmark. This is the configuration, Sysbench configuration. Let's do it here. This is the MySQL host inside the Kubernetes, the host name of the TiDB server service, and this is the TiDB port, and the DB we want to set to right to the test, and when now we start 100 and 28 stress. And we can prepare the table for this cluster. Okay. Yeah, just creating the table and insert the records in the test table and create an index, things like this. For information, the Sysbench is kind of the standard MySQL benchmark tool, and it is widely used. Okay. On the Ansible side is still deploying. We're deploying a lot of things like dashboard, Grafana, Prometheus, TiDB log. All these components will deploy for you. So that will take a little bit longer, I expect, but yeah. So far so good. Okay, on this side, you can see the prepared phrase is okay, and we can run the Sysbench workload on this small cluster. Yeah. You can see the performance is about 60K for the read, not bad. Let's try to do some. Maybe it can increase the stress. That will get a better. I think I will get a better performance. Yeah, the performance is a little bit better. And we can see what's the performance bottleneck like. I think for this workload, the bottleneck will be the TiDB server. So I will go to the TiDB node and to check what if the CPU becomes the bottleneck. Right now the CPU is not bottleneck. Maybe if the Sysbench itself becomes the bottleneck. Okay, it's good. That means we can continue increase the thread. And right now we are using 500 threads to bench the system. Yeah, have a little bit improvement. Okay. Yeah, on the Ansible side, the system have already launched. This is the relay server, and we can use SSH to connect to the and we will generate the key for every deployment. So let's see. Yeah. Yeah, you can see the TiDB is deployed. And we can also run the Sysbench benchmark for this cluster. This cluster is for this cluster is a i3-2x large node, and we can download the Sysbench package here, and we'll install the whole source dependency for building Sysbench. Yeah, basically, I just installing the Sysbench on this node. It is all the steps are in the Sysbench documents. So. remember, like I said, we have a little patch of OLTP comment.lua to speed up the data import for TiDB. And let's do the patch. Okay, this is our patched the OLTP comment WAV file. And what's the TiDB nodes here? Okay. We create the configuration file for the Sysbench. Here. And notice that the TiDB server, the private IP is here. And storage center. And do the prepare the workload. Okay. The table is creating, inserting 100K records for each table. So the total number is 1 million rows for this table. Okay, we can run the benchmark, but before that, we have very decent machines, so the thread can be larger. Yeah, you can see. Okay. The number is a little bit better than the than on the Kubernetes cluster. But since we use different hardware, but not very much, it is similar, yeah, similar hardware. Okay. For example, if we want to change the configuration of the TiDB server, how to do that? It is very easy either. So we can jump to the TiDB Ansible directory. We have a conf directory. You can see TiDB.yaml. For example, we want to open the prepare the plan cache here for the better performance. We can find the prepare here. So the by default, this option is not enabled. So I will change it to true and run the rolling upgrade. Yeah, Yeah, we have documentation about deploy TiDB using Ansible, and you can find rolling update in the method of rolling update in this document. Yeah, I can use this. Because we only need to upgrade the TiDB server, so using the tag TiDB, and the Ansible playbook will do the rolling upgrades for you automatically. So you can see the plan cache here equals to 2. Okay. And after we open the prepared plan cache, you can run the same benchmark again. Yeah, the number, you can see the number is better now. It's about 100K. We are only using 3 TiKV nodes and 1 TiDB nodes, and the performance is really good. That's all I have today. So any questions? Okay. Yeah, I will put all this script, the step-by-step tutorial on our documentation. Make sure you can reproduce the benchmark result on your cluster. So yeah, I think this is all I have today. Okay, since we don't have any questions, I will stop. I have a little meeting. Okay.